Okay, final question on all our mechanics works from this year. At time t equals 0, a particle of mass 6 kilograms is projected vertically upward from a point A with a speed of 24.5 meters per second. The resistance acting on the particle has magnitude 3 V newtons, where V is the speed of the particle at time t. Show that V satisfies that equation. Okay, so I've got my initial condition that when t equals 0, it's got a speed of 24.5. So when t equals 0, V equals 24.5. And this thing is being projected upwards, so it's going to have an acceleration upwards, and downwards it's got a resistance of 3 V newtons, but it's also got its weight. So it's got a 3 V newtons, and it's also got its weight, which is 6G. So the total resistance is its weight is causing it to decelerate, and this resistance force as well. So that's what we're dealing with. It's going to be Newton's second law again. If I take the direction of motion to be positive, I'm going to have minus 3V plus 6G equals the mass, which is 6 times the acceleration. So now I can say A is the rate of change of velocity. So I can say I've got 6 dV dt equals minus 3V minus 6G. So look at what I'm trying to achieve. I'm still going to have a 2 there, so I'm not going to divide throughout by 6 and end up with a half there. I'm going to divide throughout by 3. So when I divide by 3, I get what do I get? I get 2 dV dt equals minus V minus 2G. And 2G is 2 lots 9.8, which is 19.6. So let's write this in the same way that they've written it. So they've written it as 2 dV dt, then minus 2G, which is minus 19.6, minus V as required. Okay, so I've done A part 1. Find an expression for V in terms of t, which means I now need to solve my differential equation. So if I separate the variables, I will have integral of 2 over minus 19.6 minus V dV equals dt. Well, it's a bit ugly that way, so if I multiply throughout by minus 1, which I could have just taken at the minus 1 up there, let's do that. Let's do that. If I write that first of all as 2 dV dt equals minus 1 bracket 19.6 plus V. Okay, so I've just pulled minus 1 out, and then what I'm going to do over here now is write that as I'm tempted to take 2 over. It's not show that, is it? Find an expression. Well, let's leave it here for now. It's going to go over eventually, but let's leave it. So we're going to have 2 dv over 19.6 plus v equals minus 1 dt. There's no to the power of anything here, so that's going to be a straightforward ln, and there's no coefficient in front of the v that we need to worry about. So this side just becomes 2 ln 19.6 plus v, and this side becomes minus t plus c. Now we were given that initial condition when t is 0, v is 24.5. So putting that in there, that's going to give me that c is 2 ln of 19.6 plus 24.5, which is 44.1. That is positive, so I can just plop round brackets in that. So what am I trying to get? V in terms of t. So I'm looking for v equals. So now I'm going to have 2 natural log 19.6 plus v equals minus t plus 2 natural log 44.1. And I want v equals. So I need to bring my nat logs together. So I get 2 natural log 19.6 plus v minus 2 natural log 44.1 equals minus t. I can now combine these. It's a subtraction, so it's a divide. The 2 would be treated as a common factor. So I've got 19.6 plus v over 44.1 equals minus t. So take the 2 over and I get ln of 19.6 plus v over 44.1 equals minus t over 2. And I need to do that because now, because this is entirely embedded in that natural log function, I can now take e's of both sides to eliminate that natural log. So taking e's, I get 19.6 plus v over 44.1 equals e to the minus t upon 2. Take the 44.1 over. Take the 19.6 over. So that means I do now have an expression of v in terms of t. Back to the question. Done, done. B. Determine the time when the particle reaches its maximum height. Well, it's going to reach its maximum height when it becomes instantaneously at rest when v is 0. So for part B, particle at max height when v equals 0. So that means then I have 0 equals 44.1 e to the minus t over 2 minus 19.6, 44.1 e to the minus t upon 2 equals 19.6, so just rearranging that. Now I'm going to divide. Then I'm going to take natural logs. Then I'm going to take the 2 over and the minus, and I get t equals minus 2 nat log 19.6 over 44.1. Right then, minus 2 natural log fraction button 19.6 on the top, 44.1 on the bottom. Close the bracket. 1.62 seconds. Okay, we did use G in that, so to 1 to 2 sig figs. Just to cover our backs. And that's part B. We're not done. C, find an expression for x in terms of t, where x is the distance of the particle from A. So once again now we've got to go from this knowing that v is the rate of change of distance. So we've got dx dt equals 44.1 e to the minus t upon 2 minus 19.6. Separate the variables. All the t's are already on this side. So we're going to integrate that. When we integrate that, we get x on this side, and then here, when we integrate e to the t, we get e to the t, but when we integrate e to the at, we get 1 over a e to the at. So this becomes 44.1 times 1 over minus a half e to the minus t over 2. So that's the work you do, Mrs. John. You could do it by substitution if you would prefer. Minus 19.6. I won't make the same mistake here that I did in the second question. That becomes that plus c. So I've got to deal with the constant. So this now becomes x equals minus 88.2 e to the minus t over 2 minus 19.6 t plus c. Now the question is asking us from the point of projection. So when t is 0, x is 0. So we get 0 equals minus 88.2. E to the 0 is 1. So that will just be minus 88.2. That will be 0. So we get that. So C equals 88.2. Therefore, x equals, I'll put the c in first because it's positive. So I'm going to have an 88.2 minus 88.2 e to the minus t upon 2 minus 19.6 t. Check what they're asking me to do. Find an expression for x in terms of t and then not work out anything. So that's it. That's your expression of x in terms of t. Job done. So going back over the 3 questions then, what you're seeing is that yes, they're mechanics questions, rate of change questions, but they're pretty much pure maths integration questions, where the integration is more straightforward than you would get on a pure maths integration question. Okay, so hopefully you followed those okay. If not, please do let me know, and I'll try and find some more for us to practice.